We are Group ME33. Group members include James Rotunda, Michael Koroly, Ian Post, and John O'Toole. We are working on the forge furnace door hoisting mechanisms and partnered with McInnes Rolled Rings. So their current door hoisting mechanism is utilized on their forge furnaces. They're based off of a cable, which also utilizes sheaves, turnbuckles, bushings, support arms, and limit switches, which is driven by a variable frequency drive motor, which is activated from the fork truck cab. This furnace is used to heat up preforms or reworked rings, which then go to the press or the mill, which then give the rings their final shaping. The cables get replaced between 6 and 18 months of operation, and it takes about 1 to 2 hours. So our problem statement is to diagnose the cause of failure of the hoisting system and develop a more robust design. So from the failure analysis that was conducted, we found a static factor of safety and a fatigue factor of safety at these critical points that were defined. The static factor of safety was acceptable at all locations, but the fatigue factor of safety, which was based on a base 1 scale, this means that if the factor of safety is greater than 1, it has infinite life. If it is below, it does not have infinite life. There were a couple critical points found to be point A, B, and C because they are rotating over 2 different sheaves when the door goes up, and those 2 more sheaves also when the door goes down, which increases the bending stress in those portions. And failure was seen in these areas. Some fatigue failure and bird caging. As pictured on the bottom left is a cable that sees fatigue failure, which is that those are the strands that are flaking off from the main wire rope. And on the right, there was early signs of bird caging, which is when the strands all separate from the core of the wire. So then we moved on to stage 1 of concept generation, where we were just trying to think of systems that could possibly replace the wire rope system. And these include pneumatic chains, gears, and hydraulics. After this, we sketched up a bunch of designs and selected 4 of them, which led to further analysis. The one on the left pictured utilizes a chain drive along with the shaft, gears, and drum with cables. The one on the right utilizes many of the same parts, just with the main difference being there is a link chain in place of most of the cable in the system. The third design on the left here utilizes a shaft along with a driving chain loop and an open chain loop used to hoist the door. And the one on the right utilizes shafts and open chain loops in combination with counterweights to hoist the door, all driven by the motor. The final design selected was a link chain design. It utilizes many of the same parts, including the door arms, the motor, the drum, and the link plate, which these are pictured in red, and some new redesign parts, which include the sheaves and the mounts for the sheaves. The link chain that was utilized in this does not see bending stress the same way that the cable saw bending stress. So it is expected to last significantly longer than the current cable system. Thank you.